Okay, so I'm going to pick up where I left off, continuing on with lesson 8.1 for you. So a point estimate is just a statistic that provides a reasonable guess about a parameter. So a sample proportion is our reasonable guess about the population proportion. Sample mean is our reasonable guess about the population mean. It's the best we have because we don't know the values of the parameters. We talked about how to construct a confidence interval. You take your point estimate plus or minus your margin of error. We went through these formulas. Interpretation we're going to get to. This is something that we're going to use for multiple chapters. We are blank % confident that the interval from A to B captures the true parameter in context, whatever it is. And then when you're asked to make decisions about a claim, like I claim the midterm average was 98.3, the confidence interval just gives you plausible values, which means reasonable or believable. We'll never know the true parameter. So, just some ideas about confidence intervals. It's the interval of believable values for that parameter. We went through the structure. The margin of error. It estimates how far we expect our best guess to vary from that point estimate at the most. One thing that the margin of error does is it accounts for sampling variability due to the random assignment, or the random selection, but not bias. So if you don't have a random sample, or you have non-response bias or undercoverage, margin of error is not going to account for that. Plausible, I mentioned this before, means reasonable or believable values for the parameter. So some facts about confidence intervals. Using an interval rather than just a point, it increases our chances of being correct and capturing the parameter. This cartoon is awesome. This is Garfield. I don't even know if you know who Garfield is, but I like Garfield cartoons. If you got to read this. So it's just completely pointless. That's not giving us any information. So there's no such thing as a 100% confidence interval because that would be useless. Higher confidence levels decrease the risk of being incorrect, but the problem is they get wider and wider. So we try to find this balance. Usually statisticians use 95% as their kind of threshold. Okay, so how do we do the interpretation? I kind of gave you a generic interpretation just a minute ago. What we're going to do is look at applying that for this question here. 2 weeks before the presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? Based on this poll, 95% confidence interval for the population proportion who favor candidate A is this. So, interpreting this confidence interval is basically fitting it to this structure. So what I'd encourage you to do now is pause the video and try to fit this confidence interval into this structure. So in part A, I would say we are 95% confident that the interval from 0.48 to 0.54 captures the true proportion or population proportion of voters who favor candidate A. All right, let me move that so you can see it. So we're 95% confident that the interval from 0.48 to 0.54 captures the true proportion of voters who favor candidate A. All right, part B. What is the point estimate? What is the margin of error? The point estimate is just the average of those two. So 0.48 plus the 0.54 divided by 2, that'd be 0.51. So that means for this sample, that's your sample proportion. That's what that is really measuring. Your margin of error, what am I adding and subtracting to that? You can probably figure it out in your head, but it's nice to have a formula to fall back on if you get some messy decimals. 3%. Part C, they claim a majority of registered voters used favor candidate A. Majority means more than 50%. So no, this confidence interval does not support that. There is not convincing evidence that a majority support candidate A because 0.5 is in the interval 0.48 to 0.54. What we would need is a confidence interval that is entirely over 50%. So it could have been like 51 to 56%, something like that would lead me to have evidence that yes, they do have the majority of the votes. All right, let's move on to part 2. We're going to take a look at this. What the heck does 95% confident mean? So on your agenda, you're going to need to click on this confidence interval applet and get this loaded up. All right. Once you have this loaded up, pause the video and go ahead and work through this activity on your own. It's going to do you no good if I just work through the activity. Like, I want you to explore what's happening and figure this out on your own. Then after you've done that, come back, watch me go through it, or skip ahead if you feel like you got a good idea of it. So here goes. So I'm going to set this to 95%, which I have it at. Sample size I'm going to bring down to 5. All right. So what I have here, this green line represents the true mean. That's my parameter. So what I'm going to do is I'm going to take a sample. This point is the point estimate. This black line segment is my confidence interval. And these dots represent the actual data values for my random sample of 5. So my first question says, did the confidence interval capture the mean? Yes. Yes, it did. It captured that green line. If I repeat this 10 times, so if I do this for a total 10 times, how many of the intervals capture the true mean? 10 out of 10, 100%. Every single one. The green line goes through all of my confidence intervals. You can see the sampling variability from point estimate to point estimate. Not shocking. All right, it says to click reset. And then take a total of 100 confidence intervals. So if I sample 25 4 times. So I can see right away, let me scroll down a little bit. The confidence intervals that are red did not capture the parameter. If I do that again, there's another 2, there's 1, there's 1. So out of my 100 confidence intervals that I constructed, 94 out of 100, or 94%, captured the true mean. So for me, how many? 94. Is this surprising? No, because I had a 95% confidence level. So this isn't shocking. Watch your confidence levels as you drag the level from 95 to 99%. So as I do this, I notice I'm getting wider. They get wider. And yes, this makes sense because that's our capture rate. So I'm more likely to capture the true parameter if I have a wider interval. So reset 100 times at 80% confidence. So 80%. Okay. My percent hit, or my capture rate here, is 75%. Definitely different than what it was before. So then it goes on to ask, what is the confidence level measuring? This is really the big takeaway. The confidence level is measuring the capture rate. It is the capture rate of the parameter. What percent of these confidence intervals that you're creating should capture the parameter? Okay, change the sample size from 5 to 50 and do sample 1 interval. Oops, sorry. There's 50. Okay, so 5 was here. I sample 1 to now 50. I can see it's much smaller than it was. Actually, I should do more. So I know my sample's not on 5. There's the sample size of 10. There's a sample size of 50. There's a sample size of 250. So when the sample size increases, the variability decreases. No shock there. We've seen that a million times. So margin of error decreases. But you'll notice the capture rate isn't changing. If it's 80% confidence, it's around 80%. All right, that's it for part 2.